Hello everyone, welcome to the lecture again. In the last class, we look at various examples of the velocity and acceleration in Cartesian coordinates and planar polar coordinate system. Today, we are going to solve some examples on the spherical and cylindrical coordinate system. But first, let me look at one more example in planar coordinate system. So, here the problem statement is following. The collar A slides along the rotating rod OB the angular position of the rod is given by theta equal to 2 by 3 pi t square radian, and the distance of the collar from O varies as r equal to 18 t to the power 4 plus 4 meter, where time t is measured in seconds. Determine the velocity and acceleration vector of the collar at t equal to 0.5 second. Now, it is obvious in this question that the collar is making planar motion, therefore, we will use the planar polar coordinate, and there the velocity in r direction Vr is r dot and V theta is r theta dot. The acceleration along r is r double dot minus r theta dot square, and the acceleration along theta direction is r theta double dot plus 2 r dot theta dot. Now, it is given that r is equal to 18 t to the power 4 plus 4, therefore, r dot will be 18 into 4 t to the power 3 and r double dot will be 18 into 4 into 3 t square. Now, all the quantities in this question we have to calculate at t equal to 0.5 second. So, let us put t equal to 0.5 second. So, we get r is equal to 18 into 0.5 to the power 4 plus 4, which comes out to be 5.125 meter. Similarly, r dot comes out to be 9 meter per second and r double dot comes out to be 54 meter per second square. Now, let us find out theta dot and theta double dot, because that is required to find out the velocity and acceleration. So, it is given that theta is equal to 2 by 3 pi t square. Therefore, theta dot will be 2 by 3 pi into 2 t and theta double dot will be 2 by 3 pi into 2, and again at t equal to 0.5 second, this becomes 0.5236 radian, which you can convert into degree. So, it comes out to be 30 degree, and theta dot is 2.094 and this is 4.189 radian per second. So, now we know r dot, r double dot, theta dot and theta double dot, therefore, we can write down Vr, V theta, Ar and A theta. So, now let us look at Vr. Vr was r dot and r dot we have calculated, it is 9 meter per second. V theta is r theta dot, r is 5.125 multiplied by theta dot is 2.094 and this comes out to be 10.73 meter per second. Therefore, V can be written as 9 r cap plus 10.73 theta cap, and its magnitude will be square root 9 square plus 10.73 square, which comes out to be 14 meter per second. Let us look at the angle between V theta and VR, so that you can find out alpha equal to tan inverse V theta over VR. So that comes out to be 50 degree. Now let us look at the acceleration. Acceleration AR was r double dot, which is 54 minus r is 5.125 multiplied by theta dot square, and theta dot is 2.094 square, and this comes out to be 31.53 meter per second square. Now let us look at A theta. A theta is r theta double dot, and r is 5.125 into theta double dot, which is 4.189 plus 2 into r dot, which is 9 into theta dot, which is 2.094, and this comes out to be 59.16 meter per second square. Therefore, acceleration A I can write down as 31.53 r cap plus 59.16 theta cap meter per second square. Its magnitude A will be square root 31.53 square plus 59.16 square, and this comes out to be 67 meter per second square, and let us say the angle between them is beta. So this is tan inverse A theta over A r, which comes out to be 61.9 degree. Now let us look the velocity by the diagram. So we have this collar, this angle is given as 30 degree. The collar has a velocity along r. So r is given 5.125 meter. VR will be along this direction, and it is 9 meter per second at t equal to 0.5 second, and V theta is perpendicular to it, which is 10.732, and its resultant makes an angle alpha that we have calculated comes out to be 50 degree. So this is your V, and this angle is 50 degree. Now let us look at the acceleration by the diagram. So at t equal to 0.5 second, this angle was 30 degree, and r was 5.125 meter. The radial component of the acceleration is AR, which we have calculated. It was 31.53, and the theta component A theta was 59.16, and the resultant makes an angle beta, and beta we have find out 61.9 degree, and this was our A. So in this question we have find out the velocity and acceleration when t was 0.5 second. Now let us look at another problem. Question number 2, and the problem statement is following. The rotating element in a mixing chamber is given a periodic axial movement which is given by z equal to z naught sin 2 pi nt, while it is rotating at the constant angular velocity phi dot. Which is nothing but omega, and we have asked to determine the expression for the maximum magnitude of the acceleration of a point A on the rim of radius r, and it is given that the frequency n of vertical oscillation is constant. In this question, you can see that because of the cylindrical symmetry, the preferred coordinate choice is the cylindrical coordinate, and in cylindrical coordinate, the acceleration along the r, phi and z direction are given as ar equal to r double dot minus r phi dot square, a phi equal to r phi double dot plus 2 r dot phi dot, and a z equal to z double dot. Now, we have been given a relation between z and t. It is given that z is equal to z naught sin 2 pi nt, and phi dot, which is omega, is equal to constant. It is also given that n is also constant. And note that because we have been asked to find out the maximum acceleration of point A on the rim, okay. So, on the rim r is also constant, r is not changing. Therefore, let us see what is AR. Because r is constant, therefore, r dot and r double dot will be 0, and because phi dot is constant, therefore, phi double dot will also be 0. Therefore, AR will be 0 minus r omega square, which is nothing but r omega square. A phi is r phi double dot, which is 0, plus r dot is 0, therefore, a phi is 0. Now, let us look at AZ. AZ was z double dot, which is d2 over dt square of z, which is z naught sin 2 pi nt. So, this becomes d over dt z naught 2 pi n cos 2 pi nt, and this becomes minus z naught 4 pi square n square sin 2 pi nt. Therefore, I can write down the magnitude of A. It will be square root a r square plus a phi square plus a z square. So, this is also minus. So, minus r omega square whole square plus minus z naught 4 pi square n square sin 2 pi nt whole square. Now, note that in the question we have asked to find out the expression for maximum acceleration. Okay. Now, the maximum acceleration will happen when sin theta is equal to 1, because that is the maximum value of a sine function. So, for maximum A, sin 2 pi nt has to be 1. Let us put that. So, we get A equal to square root r square omega to the power 4 plus 16 pi square n to the power 4 z naught square. Now let us look at another problem statement. The passenger car of an amusement park ride is connected by an arm AB to the vertical mast OC. During a certain time interval, the mast is rotating at constant rate. And the rate is theta dot equal to 1.2 radian per second, while the arm is being elevated at the constant rate phi dot equal to 0.3 radian per second. And in this question we have asked to determine the cylindrical component of the velocity and acceleration of the car at the instant when phi is equal to 40 degree. Okay. Now in this question we have been asked to find out the cylindrical component of the velocity and acceleration. Therefore, we have to use the cylindrical coordinate. Now note that in cylindrical coordinate our axes were r, phi and z. Where this phi was the angle that r makes from the x axis. However, in this question it is given that the angle that r makes from the x axis is theta. Therefore, in the formula that we have derived, we have to replace phi by theta. So, let me write down the expression for the velocity and accelerations. Vr is r dot, v phi becomes v theta and r phi dot becomes r theta dot. Similarly, Vz is z dot, Ar is r double dot minus r theta dot square, A theta becomes r theta double dot plus 2 r dot theta dot and Az is z double dot. Now, it is given that theta dot is 1.2 radian per second and phi dot is 0.3 radian per second, and we have to find the acceleration and velocity when phi is equal to 40 degree. Now, from the diagram you can see that capital R, which is also R, is 4 sin phi. Therefore, r dot is 4 cos phi phi dot and r double dot will becomes minus 4 phi dot square sin phi because phi double dot is 0. Now let us put the value of phi equal to 40 degree. So we get r equal to 2.571 meter, r dot equal to 0.919 meter per second, and r double dot equal to minus 0.231 meter per second square. Now z also you can find from the figure, and you can see that z is equal to 6 minus 4 cos phi, because this distance will be 4 cos phi. Therefore, z becomes 6 minus 4 cos phi, and z dot will be 4 sin phi phi dot, and z double dot will be 4 phi dot square cos phi, because phi double dot is equal to 0. Now let us look at its value when phi is equal to 40 degree. So z becomes 2.936 meter, z dot becomes 0.771 meter per second, and z double dot is 0.276 meter per second square. So now we have the value of z dot, z double dot, r dot, r double dot, and theta dot, theta double dot. Those values we can put here to find out the velocity and acceleration. So let me first write down Vr. Vr was r dot, it was 0.919 meter per second. V theta was r theta dot, so this was 2.571 into 1.2, so that was 3.085 meter per second. Vz was z dot, this was 0.771 meter per second, and ar was r double dot minus r theta dot square, so this was minus 0.231 minus 2.571 into 1.2 whole square, comes out to be minus 3.933 meter per second square, and a theta was r theta double dot plus 2 r dot theta dot, but note that theta dot was constant, therefore theta double dot will be 0. So it will be 2 into r dot was 0.919 into theta dot was 1.2. So this becomes 2.206 meter per second square, and a z was z double dot equal to 0.276 meter per second square. So this is the answer. Now let us look at one more problem. Question number 4, and the statement is following: the disk A rotates about the vertical z axis with a constant speed omega equal to theta dot equal to pi by 3 radian per second. Simultaneously, the hinged arm OB is elevated at the constant rate phi dot equal to 2 pi by 3 radian per second at time t equal to 0, both theta equal to 0 and phi equal to 0. The angle theta is measured from the fixed reference x axis. The small sphere P slides out along the rod according to r equal to 50 plus 200 t square, where r is in mm and t is in second. Determine the magnitude of the total acceleration A of p when t is equal to half second. So, the obvious choice to solve this question is the spherical polar coordinate, and in spherical polar coordinate you have the x, y and z, you have let us say some vector r. It makes an angle theta from the z axis and its projection on the xy plane makes an angle phi from the x axis. So, this is some point P. Now, for this case we have derived the expression for the acceleration, and our AR was r double dot minus r theta dot square minus r sin square theta phi dot square. Our A theta was r theta double dot plus 2 r dot theta dot minus r sin theta cos theta phi dot square, and A phi was 2 r dot phi dot sin theta plus 2 r dot phi dot cos theta plus r sin theta phi double dot. Note that when we derived this expression, we said that the angle phi is the angle that the projection of r makes with the x axis. However, in this question that angle is given as theta. Therefore, we have to make the transformation. In our formalism, we have to replace this phi by theta, and in this formalism the angle theta was the angle that r makes from the z axis, which will be replaced by pi by 2 minus phi, because that angle will be pi by 2 minus phi. So, let us make these transformations, or we can call it the change of variable in the above equation. So, we will have AR equal to r double dot minus r theta dot will becomes phi dot. So, it will be minus r phi dot square minus r cos square phi theta dot square. A phi will be minus r phi dot plus 2 r dot minus phi dot minus r cos phi sin phi theta dot square, and a theta will be 2 r dot theta dot cos phi plus 2 r minus phi dot theta dot sin phi plus r cos phi theta double dot. This is the acceleration along r, phi and theta direction after having the change of variable. Now, in the problem statement, r is given, r is 50 plus 200 t square, and we have been asked to find out the acceleration etc. at t equal to half second. So, therefore, at t equal to half second, this r comes out to be 0.1 meter, and r dot will be 400 t, therefore, it will be 0.2 meter per second, and r double dot will be 400. Now, let us look at theta dot. It is given that theta dot is pi by 3. Therefore, theta will be pi by 3 into t, and theta double dot will be 0. Now, at t equal to half, theta becomes pi by 6, and phi dot is also given. Phi dot is 2 pi by 3. Therefore, phi will be 2 pi by 3 into t, and phi double dot will be 0. At t equal to half second, phi will be pi by 3. So, now we have r dot r double dot, theta dot theta double dot, and phi dot phi double dot. This we can put in equation number 1 to find out what is ar, a phi and a theta. And when you do that, then ar comes out to be minus 0.0661 meter per second square, a phi comes out to be minus 0.855 meter per second square, and a theta comes out to be minus 0.1704 meter per second square. Therefore, the magnitude of A will be square root AR square plus A phi square plus A theta square, and this comes out to be 0.904 meter per second square. With this, let me stop here. See you in the next class. Thank you.